Alrighty. Class.
Yes.
Danny. Yes. Alright. So here's another one with the fractional power, where is you are taking a power raised to a fraction. I'm going to plug it in. I'm going to show you a couple things as we do this. So the limit as x approaches 8, x plus 1. So that's basically going to be 8 plus 1 raised to the 3 halves. And then if I remember from what I was telling you, the top is a power, the bottom is a root. And they can go in whichever order that you want. They could actually, you could do the power first or the root first. So 8 plus 1 is 9. So it's asking for the square root of 9, which is, what's the square root?
Oh, 3.
3. So it's now 3 to the third power, which is 27. Or if you want to just rewrite it like this instead, you don't like your 9, so it's a square root of 9 raised to the third. Wait.
Which
No, wait, hold on. Yeah. I'm going to do it like this so I don't confuse you. Like that.
Okay.
This might be an easier way to look at it or even to consider it. Yes? Good. All right. Let's keep going. Limit of a polynomial. If it is a polynomial function, then you could just plug it in. Again, right here, finding the limit by plugging in. So this is kind of like what we just did for the showing on the problem for the AP question. So if I just plugged it in, that's going to be 4 times 3 squared minus 3 plus 2. So 3 squared is going to be 9 times 4 is 36 minus 3 plus 2. So it's going to be 35. 36 minus 3 is 33. 33 plus 2, 35. All right, now this next one's going to be kind of tricky because we're plugging in a negative. Whenever you plug in, I want you to plug in using parentheses, otherwise you're going to lose it. 7 parentheses negative 1 to the fifth plus 4 times negative 1 to the third minus 2 times negative 1 squared. So this negative 1, it is just going to basically change my signs. So if I take negative 1 to the fifth power, that's going to be?
Negative 1.
Negative 1. Okay, good. So all the odd exponents, it's always going to be a negative 1. What about the even exponent?
It'll be positive.
It's going to be a positive because that's a negative negative. So you'll have 2 of a kind, so it's going to be a positive right there. So I'm going to go ahead and plug this in. So that's a negative 7. That's going to be a minus 4. This is going to be a minus 2. Now, as we plug this in, negative 11, negative 13.
Negative 13.
Yes, no, maybe, possibly. Good. All right, limit of the quotient. So it's basically if I have 2 functions in there, I could break them up into 2 different limits, where the bottom limit cannot be 0. Therefore, it would be undefined. This is my average rate of change. Now, highlight, underline, circle this one right here because the average rate of change is important. That's just the slope formula. And whenever we're doing this, all we're doing is we're evaluating the endpoints. So I find my x and my y from my endpoints, and then I just do the slope formula. That's all it is. Just find the slope in between those 2 points. I know it looks all fancy and all that, but it's really not. Okay? Find the average rate of change using this from 2 to x, where x cannot equal 2. So this is an AP question. I want you to plug in using this. I want you to try this one yourself. It is straightforward. Have a trinomial that you're factoring here. Right, so it's a type of combination. It would have been about two sides. It's almost like that's what we're saying. All right, so if you got to the trinomial, let's see. So if I'm plugging in from points 2 to x, so I'm going to start with my f of b, so that's going to plug in f of x, which is x squared plus 3x. So it's basically just my function, plug in my x, it's that, minus f of a, so that's going to be 2 squared plus 3 times 2. That's going to give me 10. Yes?
Yeah.
Positive?
Positive 10.
Very good. Okay, so positive 10. So it's going to be like this. And over b minus a, my b is,
2.
nope, x. Remember, it's a comma b.
Okay.
So it's x minus 2. And now by factoring the top, it's going to give me what multiplies to be negative 10, but add together to be 3. So if I do 1 times 10, that's 10, but doesn't add. And 2 times 5, those will give me a 3, but because it's a negative 10, one of them has to be a negative. So from right here, it's got to be a negative 2, because if I add those together, I'm going to get a positive 3, and that's what I need there in that middle term. I get x minus 2, x plus 5, all over x minus 2. My head's in the way. I'm sorry. Yes? And then right here, x minus 2's cancel. So my limit is going to be x plus 5. Or the average rate of change for that one, not the limit. No. Actually, I got some Filiberto's napkins.
Yay.
Would those work?
Yeah.
Okay, good. All right, the next one. Find the limit as x approaches 2. Okay, right there. Now we're finding the limit for this one right here. So, can I just plug in average rate of change, find the limit as x approaches 2 of the average rate of change for this. So that gives me my average rate of change, which I already did, right? I already did the average rate of change. Now can I just plug in the 2?
Yeah.
Yeah, and that's going to give me a limit of
7
equals. Because right here, using algebra, if I still had the 2 down, or the x minus 2 on the bottom, would I be able to actually still have that? Because on the bottom, isn't that 2 minus 2?
0 undefined.
0 undefined. I can't do that right there. So that's why algebraically I was able to cancel that out. And whenever I cancel out something that's going to give me a 0 in the denominator, that is referred to as a whole. That is a whole. On my graph, it would look like it would, if I'm graphing this, it would look like it's continuous. But it's a whole. It is equal all the way up into that singular point, but it's not equal at that point. There we go. So this is our difference quotient. This is what we have done before. So we could actually just plug in and use this. We're finding the limit as h approaches 0. That's what this one's going to come up with. The limit as h approaches 0. Find the limit of a difference quotient. So for a, find the difference quotient. So we're doing the limit for this one right here. So I'm going to plug this in. So it's going to be 2. And every place that there's an x, I'm going to replace it with what?
X plus H.
X plus h. close squared minus 3x plus h close plus 1 all over, wait,
You have to add it.
and it's going to be minus f of x, which is bracket or parentheses right here, either way, 2x squared minus 3x plus 1. All this is going to be over my h. Now, why did I put a bracket right there? I could have used a parentheses too, but why did I put that in front of my f of x? Why did I do that? Why didn't I just write it there?
Separate it.
Almost. You have to subtract the entirety of the function. Because if I did not put a parentheses or a bracket right here, you would only be subtracting the first term in this polynomial. Bracket or parentheses. Because if I were to just write the function like this, wouldn't that mean I'm just subtracting the first term?
Yeah.
Yes, and that's important. There's a huge difference. So now this right here means I'm subtracting the entirety of it. So when I do this, I have to distribute the negative into that whole polynomial. Make sense so far? Okay, so we're going to do the algebra, but I hate scrunching on the bottom of the screen, so I am going to... Okay, good. Let's see. It was 2x plus h squared minus plus 1 Now, from here, I'm hoping you guys will remember the process to try and do my squares really quickly. So this is going to be 2 times, if I square that x plus h, I'm going to get
It would be
x squared
plus 2xh
2xh
plus h squared.
h squared, very good. And there's 2 because that 2 is out front of that. I have to distribute a 2 in there eventually. Minus, I'm going to distribute this, 3x minus 3h. And then as I keep distributing, it's going to be minus 2x squared plus, because I'm distributing here, 3x, and then minus 1.
All over h.
I'm missing a plus 1 here, and yes, I am.
Yeah.
I'm missing a plus 1. I thought I did say it, but I still did not write it. Plus 1. So after this piece right here, there's this plus 1. Come on. Then minus 2x squared plus 3x minus 1. There we go. So as I go through, and all this is going to be over h, so I don't lose that, I'm going to distribute my 2 in here. So 2x squared plus 4xh plus 4h squared minus 3x minus 3
4h squared.
4h. Oh, you're right, 2h squared. Wow, good call. All right, remind me to throw a candy at you for that one. You were paying attention. Good job. Where were you there, Denny? You had one job. Okay. Plus 1 minus 2x squared plus 3x minus 1. And it's still over h, but I want to combine all this first before I get too far into this. So let's start with my minus 1 and plus 1. Those go away, right?
Yeah.
Minus 2x squared plus 2x squared. Those go away. plus 3x minus 3x so all those will combine to cancel out, right?
Yes.
So I just rewrite what I have left over, and I'm going to start with my highest degree. So that's going to be my 2h squared plus 4xh minus 3h all over h.
Just take an H
Now you can factor out that h. By factoring out that h quantity 2h plus 4x minus 3 all over h. So those h's will cancel. And now can I plug in 0 for h? Now can I take the limit as h approaches 0? By canceling that out, I've removed that. So in this formula here, the h is now gone. So let's see. Plug in 0. 2 times 0? 0. Okay. And then I'm left with
4x minus 3.
4x minus 3. So now that we have that, find the limit. We did the, right here, the difference. Okay, find the limit h approaches 0 of the difference quotient for this. There we go.
Because 4x minus 3.
Now, does that make sense? Or is that nonsense? Is that crazy? What is that one? I don't know that one. Money? Oh, that one's money? Okay. I thought you were trying to throw me up a little hard. Okay. Okay. Okay, good. All right, so I'm going to leave off there because guess what? We're done with that now. And then we're going to pick it up again on Wednesday with the 1.3 with continuity. So please work on your assignment. If you have questions, I want you to bring it up first thing at the beginning of class tomorrow.